All right, everybody. So I am going to work through, I believe this is practice problem number 21. This is a limiting reactant problem. And this is a good one because, well, limiting reactant problems are generally pretty challenging. Now, what this question reads or says is pure magnesium metal is often found as ribbons and can easily burn in the presence of oxygen. Okay, so what we got there are two reactants, Mg and O2. When 2.63 grams of magnesium ribbon, 2.63 grams of Mg, burns with 7.94 grams of O2, white light and a white powdery product are formed. Enter the balanced chemical equation for this reaction. Be sure to include all physical states. Okay, so this Mg plus O2 is going to yield magnesium oxide, MgO. This is an ionic compound. This is one that is pretty reasonable for you to be able to deduce because of the fact that, well, our only two reactants are magnesium and oxygen. Now, a fair question would be, well, how do we know that it's not MgO2? Well, one way that you know that is you have to think about oxidation reduction. Well, magnesium here with S as the state there, physical state there, what is the charge on that? The charge is 0. Okay, now O2, that is a diatomic molecule. Each oxygen is going to have a charge of 0 as well. Now, when they come together, they're going to form an ionic compound, and that ionic compound is also going to have an overall charge of 0. Now, magnesium is a group 2 metal. So when it is a part of a compound, it's going to have a +2 charge. Oxygen, when that is a part of an ionic compound, it's going to have a -2 charge. So a +2 charged ion and a -2 charged ion, well, they're going to basically cancel one another out. All right, so those are our reactants and those are our product. Okay, now how do we balance this? And let me go ahead and add the rest of this here. We're going to form solid. Okay, so we have this gaseous oxygen reacting with our solid magnesium. How do we balance this out? Well, what we're going to do is we're going to have to balance our oxygens. We'll put a 2, and I'm going to change colors to blue. We'll put a 2 out in front of there because that's going to balance our oxygens. Now, what's going to no longer be balanced? Well, our magnesiums. Now, can we balance that? A 2 right there. Done. Fantastic. Now, we're given two masses. We're given the mass of magnesium and the mass of oxygen. The question asks us to enter the balanced chemical equation. Done. Okay. But then it goes on to ask us, what is the limiting reactant? And we basically have to figure that out. All right. Now, when you think about a limiting reactant, the presentations that I showed y'all had a couple of different strategies. In fact, a total of 3 different strategies and techniques that you could use to solve and identify a limiting reactant. Well, what we want to do is we want to figure out the number of moles of magnesium and divide that by our coefficient. Well, our coefficient for our balanced chemical reaction is 2. Okay, we want to then get the number of moles of O2 and divide that by our coefficient in our balanced chemical reaction, which is 1. Now, whichever one of these is lower, that's going to be our limiting reactant. So our moles of magnesium, how would we figure that out? Well, we'd have to have the periodic table. The periodic table tells us that our molar mass for magnesium is 24.305. So I'm going to say 2.63, 1 mole, 24.305. So I'm going to punch that into my calculator, and I see that that value is, calculator, there we go, 2.63 divided by 24.305. That is going to be 0.108. Okay, so that value I don't really need to worry about, that is my number of moles. I can divide that by my coefficient, which is 2. This value right here is not going to have any units. So 0.108 divided by 2, you probably saw this coming, 0.054. Okay, so that's a quotient. And what I need to do is I need to simply figure out if Well, my other value is higher or lower than that. Okay, so I have 7.94 grams of O2. Well, O2 has a molar mass of 32. So 7.94, 32 grams is 1 mole. O2, this is equal to 7.94 divided by 32 equals 0.248. Well, that's my number of moles of oxygen. Divide that by my coefficient, which is 1, and I get, lo and behold, 0.248. So now all that we need to do is we need to compare these values, this 2.4 or 0.248 and 0.054. Which one of them is lower? This value, this quotient for magnesium is lower. Therefore, magnesium is my, and I'm going to write LR, or my limiting reactant. And what that means is that my O2 is in excess. Okay, so this question has multiple parts to it. Now, one part was balance our chemical reaction. Done. The next part was identify our limiting reactant. Done. Now, the next part, or there's two more after this. The next part reads, the reaction goes to completion, but in the process of recovering the product, some of it was lost. The percent yield for the reaction was 84.3%. How many grams of our product are recovered? Okay, so what I'm going to do is I'm going to erase, well, a considerable portion of this. I don't need to worry about the mass of O2. I don't need to worry about the moles of O2. I don't need to worry about my quotient for O2. All that I need to worry about is I need to focus on, not worry, I'm not worried. I need to focus on the mass of magnesium that I have. So I'm going to say 2.63 grams of magnesium. What I want to do with this question is I want to first figure out, well, how much of my product is actually going to be generated. Then I'm going to use my percentage, that 84.3% yield. So what I'm going to do is I'm going to set up a kind of lengthy dimensional analysis. 2.63 grams of magnesium. I need to convert that to moles of magnesium. So 24.305 grams of magnesium is 1 mole of magnesium. Okay. Now that I've converted into moles of magnesium, I want to relate my moles of magnesium to my product. 2 moles magnesium. Well, that's equivalent to 2 moles MgO. 1 mole MgO, because this is my other product, I need to know the molar mass of magnesium oxide. Magnesium oxide is going to be, well, 24.305 plus 16, which would be approximately 40.305 grams of MgO. All right, so effectively, I'm ready to go because I've converted my mass of magnesium to my moles of magnesium. My moles of magnesium to, and I've related those moles of magnesium to my moles of magnesium oxide, then my moles of magnesium oxide to my mass of magnesium oxide. So I'm going to take my values, 2.63 times 2 times 40.305 divided by, and that would be 2 times 24.305, which would be 48 point, that would be 61. And I get 4.36 grams of MgO. That's my mass of magnesium oxide that I would produce if everything went perfectly. So that's a worthwhile number to keep in mind. But then it says, well, some of the product was lost. The percent yield for the reaction is 84.3%. How many grams of the products are required or recovered? So I can just take this number, this 4.36, that's a 100% recovery, and I'm going to multiply this by 0.843. So 4.36 times 0.843 equals 3.68 grams of MgO. Done. Okay. Now, this right here is when 84.3% of my substance is recovered. I'll put a little star here. The next part of the question reads, how many grams of the excess reactant remain? Assume the reaction goes to completion. Okay, so this effectively says when you use all of the magnesium, 2.63 grams of magnesium, it's going to be completely consumed. Now the question is, well, how much of that O2 is utilized? Okay, so for this last part of the question, I'm going to carve out a spot right here. So 2.63 grams, 24.305 grams of magnesium. 1 mole magnesium. What I want to do with this is I want to relate my magnesium to my other reactant, which is my O2. So I'm going to say 2 moles of magnesium, 1 mole O2. Now I'm going to take that 1 mole O2 is 32 grams of O2. What I'm going to do here is I'm relating my mass of my magnesium that's reacting to my moles of magnesium, and I'm relating my moles of magnesium to my moles of O2, and then my moles of O2 to my mass of O2. So I'm going to be able to, with this, figure out how much O2 is actually utilized. And then I'm going to say, well, of the initial amount of O2 that I had, how much of it's left? So I'm going to say 2.63 times 32, because 2.63 times 1 times 1 times 32. I'm going to divide that by, well, 24.305 times 2, or 48.61. So of the 2.63 grams of magnesium, that reacted with 1.73 grams of O2. Now, that's not the answer to the question. This is kind of an involved question, but nevertheless, it's a really good practice question. What we need to look back on is, well, how much O2 did we actually start with? We started with 7.94 grams of O2. We used 1.73 grams of O2. Therefore, we have 7.94 minus 1.73 equals 6.21 grams of O2 remains. All right, a lengthy problem, but nevertheless a good one. I hope this was helpful. Have a good one. I haven't stopped recording.